Don's Manufactory. Just been working on my lathe a little bit, working on the parting tool. I just had to get out my end mills and do a little machining on this tool to see if I can get it to be more reliable. I'm still struggling with getting my first Yahtzee. I kind of got one the other day, but not really. Today I am working on mapping, getting the tools together I need to map the suspension. Hey, it's April 11th. What the heck is going on here? What I have to do is map the movement of the spindle. Because we have control arms that are, oh, yay long, this thing travels in an arc. The steering links do the same thing. They connect here, but they're connected to the drag link up here, and so the steering link makes an arc as well. So the idea is, what are those two arcs doing? If I didn't have any bump steer before, okay, for those of you that don't know what bump steer is, that's when the arc of the spindle and the arc of the steering rod do not coincide. They don't match up. So if we have different arcs, then what can happen is, as the spindle goes up, it can cause the spindle to toe in or toe out. It could do either one. So basically, when the wheel starts going up and down, instead of tracking, looking straight down the road with whatever toe setting you have, as it goes up and down, it is turning either in or turning out. And that's what bump steer is. Every time you hit a bump, it tries to steer the car. So if you had a little bit of toe in with the spindle going up, imagine you're turning a left-hand corner. This is the right-hand spindle, and let's say it toes in. You start shifting the weight. This spindle goes up, the spindle on the other side goes down. This one steers into the corner, and so does the one on the other side. So as soon as you load the car in the turn, it wants to oversteer. Or if you're going over a bump on just one side, you'll hit the bump and the car will want to just, every time you hit a bump, it wants to go left or right. The idea is that when you hit a bump, or there's any kind of a steering load, weight transfer, that it doesn't create a steering movement of the spindles. So that's what I'm going to do. I'm going to strap a laser onto the spindle. I'm going to shine it up here to the front to a target, and I'm going to map the curve of the spindle without the steering link hooked up. Then I'll hook up the steering link, start from the same point on the little curve that I'm plotting on the paper up here, and then I'll map the curve after the steering is hooked up. And we'll see how much it's changed. They've got the steering angle. The steering arm is down below this section here. See that? The center pivot on the ball joint is 2.5 inches below the spindle center, which puts it, that puts it about here. Not quite, so right about here. So the steering joint is below the ball joint center point. So that means that when this arm travels in, it's not following the exact curve of the lower ball joint, which isn't going to change. I'm doing no modifications to the lower swinging arm or lower control arm. The top one has been moved down, so the spindle will lean in. The question is, what's going to happen to this? How much change does that leaning in cause on the steering angle? So that's basically what I'm doing. I'm just trying to figure that out, and I figure the best way is to just map the two curves, and that'll tell me what's going on. I'm really curious about this because I can't imagine that I can change the camber curve of the spindle and not affect the steering curve as well. I could plot the upper position with and without steering, and then plot the lower position with and without steering. That would really tell me what's going on. The original position has a positive camber curve. Anyway, so that's the project today. I don't know as you need to see all of that in time lapse. I'll just stop every now and then and show you where I'm at and what I'm doing, and so you can get an idea of my setup and what I'm trying to accomplish. I'm just going to use the spring perches. I'll weld a flat plate on the end so I can just bolt this down to the spring perch, and then it'll stick up through where the shock goes, and it'll have a piece of angle iron or something at the top, and I'll have a wing nut on it, and that way the spring perch can compensate for the swinging arm movement, and I can just screw this thing up and down and use it to precisely control the position of the upper control arm. That's what I'm going to be doing. So here we go. Okay, I haven't even started measuring yet, but there the toe is set correctly. And up with the, notice that now it's toed out. And then when it goes down, it's towed properly again. So, what happens when the camber goes negative? So, I just push it back. You'll notice not only is it tipping back, but it's also towing out. When the camber goes positive, it's the other way around. I get a toe in. What happens when caster goes negative? Just a little bit of toe in. When it goes positive, it toes out. Okay. So what does that mean? When the spindle moves on this axis, the toe does not change. When it moves on this axis, it does. So a positive caster and a positive camber going in this direction keeps the bump steer at 0. That's the way the steering was originally designed. What I've done with the Shelby drop is change that positive caster into, or camber, into a negative camber, which now moves it on this axis. Well, on this axis, the toe is going to change, or the steering angle is going to change. And that is what happens. There's no escape from it. If you do the Shelby drop and you put a negative camber curve on it, you are going to have bump steer, period. So the question remains, just how much bump steer is that with the amount of suspension travel I'm going to have? Well, here's my setup for trying to figure that out. I just couldn't keep the spindle stable without the steering hooked up. So I've got some stuff I can do, but I got to figure this out. Parts came today, so I've got a new upper control arm bushing in there, and it's got the new ball joint. So this arm is all ready to go. You guys missed all the excitement. The house down the street burned down. It was the last zombie house in our neighborhood. They've been using candles and burning stuff inside the house, propane, heaters. Anyway, they managed to burn the house down. Here's my control arm, all finalized. I don't know if you can see that in the picture, but the shaft is one turn that way. Helps with the caster. I still don't know whether I'm going to have tire interference problems over here. Now what I have to do is clean up and paint the shock tower. Well, turns out my shock tower was cracked from there to there and down to there, and the control arm had worn a hole in the shock tower right there. Amazing. I had never noticed anything like that. I did leave the original holes in case, after all of this, I don't like the negative camber curve. I figured out I've been having a hard time getting empirical data, but the best I could figure out, let's see, for 3 inches of suspension travel, I get 0.2 degrees of toe out. So that 0.2 degrees worth of toe out will make the car jump over 2.3 inches in 1 second. That sounds pretty noticeable to me. So I'm pretty sure I'm going to have to do bump steer modifications to fix that. Basically, from what I've calculated, probably the outer tie rod needs to be lowered about 1/2 inch. Here's my strut rod off the driver's side, and you can see how much water damage, rust damage there is here. The water sits underneath the rubber, and the washer sits on here like this, and then the rubber sits like so, so water gets in there and rusts this portion out. And one would probably think I should just buy new ones, but since I have to weld and re-grind, or turn on the lathe, I should say, the shoulder, while I got the welder out and I'm welding and doing stuff, I might as well just weld this stuff up, and I'll turn the whole thing down nice and fresh and rebuild this shoulder up here. So that's what I'm going to do. Yeah, if you look right here, you can see it's bent. Maybe that's my four-wheeling. Okay, so here's the one I've already completed. I've got, I painted the washer silver just because this part here has not been plated, so it'll rust if I don't. Alright, and you can see how I welded this one up. If you look at it real close here, you can see that the shoulder has been turned down that 100 thousandths, and I actually left a little more diameter so it fits the washer tighter. Hello, welcome to Don's Manufactory. Well, still working on suspension. Yesterday I got the strut off the driver's side all done, so welded up the rust damage here and welded up and moved the shoulder. Trying to decide whether I should get new rubber bushings. I mean, these are still in good shape, but when these things go haywire, oh man, your suspension is really weird, especially when you hit the brakes. The car tends to hunt left, hunt right as the wheels move forward and back. It's amazing. They do move a lot when you slam on the brakes when it's compressing these rubbers. Okay, so this is set up the same way. It's got the sleeve and the, well, I guess I'll just show it to you. It's recessed 300 thousandths there. So I lost 100 thousandths here when I moved the shoulder back, but I'm compressing the rubber 300 thousandths on this end, which means that the strut rod will move forward 100 thousandths because of the shoulder moving, and then I am compressing the rubber an additional 200 thousandths, which should pull the strut rod forward another 100 thousandths. Yeah, that's the plan. So there it is. It's ready to go back in. I got it straight. I don't know if you can see that, but I ended up getting it within about 20 thousandths. Good enough that I could get it on the lathe and turn it, so it worked good. Actually, today I can assemble my suspension. I thought I'd show you a little something about alignment shims. I ended up making my own, mainly because you can't buy these anymore. About the biggest ones you can buy, which aren't bad, is this size here. But the ear isn't long enough for the hole to be above the control arm. So they're hard to use. The idea is that when you're figuring out the alignment, you can just stick a screwdriver in there and pull the entire pack out, make your change, and then put the whole pack back in as a unit, and you can hold them without them turning and going weird. One of the problems I had with my car was that ones this size were being used, and they just don't provide enough support. So here's the control arm. When you look at the spot here, this doesn't provide enough surface area, and I think it increases the load, sort of torsional load or whatever, not torsion, but stress on the metal in the shock tower. On my car, the spot where they had stacked a bunch of these in, the shock tower was cracked. So I much prefer a larger spacer like this that offers a lot of support. And also what I'm doing is I'm using thicker spacers. So primary is, you know, I'm going to call them permanent spacers that go in right there. The hole is a little off center so that it'll hang like this and it won't turn, so that it clears the seal for the shaft. And then these spacers can just be on the back here. And the idea is to have stronger things of a larger size so that it puts less stress on the shock tower. Anyway, so yeah, I've got some permanent ones here. These are 1/4 of an inch thick. I need 2 of these on the driver's side. On the passenger side, I've got 3/16. So just these permanent spacers alone provide for the caster adjustment. They're off by a 1/16. So on the passenger side, it only requires 2 133,000 shims to get the alignment, and that's it. And it's set up at 4 degrees caster and 0 camber. So anyway, that's my idea. I've got 77 thousandths, got 105 thousandths, and 133 thousandths. You know, this isn't an original idea, of course. I only had 2 of the original shims left over from olden days, and that's the size they are. On my car, there were huge stacks of these type of shims on there too, that are used for body shims, for body panels. So the last time I had it lined up, there was just a smattering of different kinds of shims in there. It was nuts. Well, everything is assembled. One note is that the driver's side, when the caster and camber are set identical to the passenger side, the spindle is 1/16 of an inch further forward. Isn't that interesting? Even though everything measures the same around except for the distance from the ball joint to the torque box. Yep, over here too. It's all in. Also, I no longer have to use a spring compressor. These springs, after the Shelby drop, these springs just go in. Once the shock is bolted up, it's held in place. But with the suspension fully extended like that, I can just put the spring in without any compressor. I guess that's kind of cool. Thanks for watching. Later.